Okay, next, last thing we're going to go over is this it's up, over, and down worksheet. I'm just going to kind of show you the first problem and the fourth problem and just go over this technique. You may, after you've done this worksheet, you may not want to do it anymore like this, but we're going to kind of quickly show this. Everybody look at number one. So number one talks about, says how many grams of nitrogen are needed to produce 30.6 grams of ammonia. So again, we're going from mass to mass. It's grams to grams. So I'm going to show you this technique by which you kind of look at it and set up the problem so you can kind of map it out before you do it. And then I'll do it on this piece of paper in the background. So the balanced equation, I'm going to zoom in on it just so you can see. I'm going to write some stuff underneath this. Make sure you can kind of see that. You have it in front of you anyways. It's number one. So first is the given. The given is 30.6 grams of ammonia. Ammonia's over here on the product side. I'm going to write it under other because grams is other. Okay? It's not moles. It's given in grams. All right? Now, it asks to find how many grams of nitrogen. So I'm going to go over here to where nitrogen is on the formula and just put a question mark grams because that's what I'm trying to find. Now, this up, down, up, over, and down, sorry, not up, down, up, over, and down method asks you to do this. Basically, if you are not in moles, it says to change to moles, move up. So that's supposed to be an arrow, not very good. You know, I'm not the best artist, but that's an arrow. So you're going to change grams to moles using a molar mass of NH3. I'm going to show you that next, but in a second I'll show you that. The next step would be, since we're in moles, if I change from grams to moles, is do a mole ratio step. So I'm going to compare that ratio, specifically the number 2, draw a line over here, to that ratio, specifically no number, so the assumed 1. So we're going to do a ratio step second. So that's the up, that's the over, and then the down. If it asks for grams, again, which it does, then I'm not going to stop at moles at the ratio step. I'm going to go now down a step and convert using molar mass back to grams. So on your paper, if you want to do this, do it for a couple of them and do it for this worksheet. And then after that, kind of do it as I'm going to show you here. So I'm going to rewrite the problem underneath, and you're going to show you how that up, over, down method kind of basically is a way to check your work and visualize what you're doing. So I'm going to rewrite the equation. So it's N2 plus H2 NH3. And to balance that real quickly, it's 3 and a 2 there. I'm going to move that over just a little bit, pan out just a little bit because I'm writing a little larger for you. So you can see that. Okay? And it says we have 30.6 grams of ammonia. So again, I like to put, here's my given, 30.6 grams. This could be a step in the up, over, and down method as well. Okay, and then we're trying to find this nitrogen, and specifically grams of it. How many? Okay, so I'm going to rewrite the given, 30.6 grams NH3. Equation's already balanced. It was given to you that way. If it wasn't, we'd need to do that first. I move grams to the bottom. Moles on top. Make sure you're writing the substance as well. I kind of omitted that first one. All right, so we go from grams to moles. What do we call that step again? That is a molar mass step, because we're using the numbers from the periodic table. I think we used ammonia earlier, but I'm going to write it up here. 1 mole, I believe, is 17.04 grams. Because we have 14.01 and 1.01 times 3. So 17.04 grams is your molar mass. Now we've canceled out of grams. We've gone up. Now we're going to go over. We're going to do the molar ratio step. Okay, so now we're going to a mole ratio. I'm going to pan out just a little bit more. Okay. Moles of ammonia goes to the bottom. Moles of nitrogen on top. Okay, mole to mole. So I know it's a ratio step. Now look at the balanced equation. There's a 2 in front of ammonia. There's no number, or the assumed 1, in front of nitrogen. So it's 1 to 2. That's my mole ratio step. Now, if the question asks for just moles, I'd be done there. But it asks for grams, so I need to do one more conversion. I move moles to the bottom of N2, grams of N2. 1 mole is 28.02 grams. Okay? This also, not a very good mark there, is a molar mass step. Cancel out moles. So now I just do my math. And you can rewrite it if you want. I'm just going to point to it and do it on the calculator here. So I have 30.6 times 1 times 1 times 28.02. So really it's just 30.6 times 28.02. Enter. And then on the denominator side is just 17.04 times 2. So I need to divide that answer divide the answer from the top by open parentheses 17.04 times 2, close parentheses, enter. And I should get this number, 25.2 grams of N2. Again, start with 3 significant figures, end in 3. I think you got 25.16 maybe. So we end in 3 significant figures. So that's how you do basic mass to mass. The only new thing you have to do is if you look at number 4, there's one difference, and I'm going to give that to you right now. I'm going to pan in or kind of zoom in on number 4 for you. If you look at number 4, see how it's giving it to you, given in liters, in this case of acetylene gas. So liters, I'm going to give you that quick conversion right now, and then you can do them all the same. Liters converts as follows. 1 mole of any gas is equal to 22.4 liters. Okay? 1 mole of any gas is 22.4. That's all you need to know right now, and that is any gas at standard conditions. STP is what we call it. Standard temperature and pressure. So that's your conversion. Just like we learned molecules, ions, atoms, and formula units, they are 6.02 times 10 to the 23rd in 1 mole. 1 mole of any gas at STP is 22.4 liters. So anytime you get to a problem like in number 4, where it talks about moles and then eventually liters, when you convert liters to moles, you use 22.4. So you should be able to do the rest of this worksheet. Again, use a separate sheet of paper, work both sides, and make sure you show all your work.